welcome back to the Professional Education D capstone project. This video we will mainly talk about the feedback from the one-on-one meetings last Friday with our students. We have received some very positive feedback from students. Like some of them mentioned that they have much better overview now with the railway system, and they can really consider the railway problems from different perspectives, namely the long-term performance, design, and operation. So we are really happy to hear that, and thank you for your positive feedbacks. And I also selected some interesting questions and that I want to share with all of our students. The first one is asked by a student from the group transition zone. He asked, by a good design, if the influence of the stiffness irregularities at the transition zone can be totally mitigated. Here, behind me, there's a demonstration transition zone located in our railway lab in TU Delft. We can see that there's a demonstration train. It runs over different track structure. There's a balanced track structure, there's a non-balanced structure, and here we have a transition zone. When we talk about the track stiffness in the railway, we can not only focus on the static stiffness, but we need to focus on the dynamic stiffness. For the dynamic stiffness, the vibration behavior, the dynamic behavior of the train, also the substructure, will influence the stiffness behavior. In the open track, like here, we consider this small section as an open track. The dynamic stiffness on the sleeper and in the middle of the sleeper span will be different. And for the transition zone, there will be some more uniqueness or the specialization of, for instance, we have the free end here. Normally, when we have the transition zone approaching to a bridge, then this part is a river or canal, and we have a free band here, and the vibration cannot transmit it to the subground. There will be the vibration reflection, and this will also influence the dynamic stiffness of the transition zone, also to the track. So we cannot really make a perfect transition zone that gives a totally smooth transition to different track structures. This can also be applied to the analysis of the switch and crossings. For the switch and crossings, the problem can be more complex because we not only have the stiffness irregularity, we also have the geometric irregularity. There's a gap from one rail to another rail, and that will also influence the dynamic behavior, also induce the impact as a switch and crossing. So the answer is no. So we cannot always have we always have to have some special treatment to this weak spots of the railway tracks. And the second question is the influence of the maintenance, structure degradation, and dynamic behavior. For instance, when the students mentioned that when the tamping activities carried out, there can be the influence to the vibration of the track structure, like one example is that the stabilization tamping frequency is about 50 Hz or 45 Hz, something like that, and that can be similar to the dynamic to the resonance of the bridge. So if the tamping is carried out as a transition zone, that may somehow influence or even damage the bridge. So it's a very good thinking to combine the design and long-term performance. Indeed, when we do this kind of long-term maintenance work, or we want to improve the long-term performance of the track, we need to take design into consideration. we for the transition zone, we need to think about what kind of sleepers or the sleeper pad are used, what kind of materials are used, and what kind of soils are there. Those are related to the design elements, and when we do the maintenance work, this should be considered. Also the dynamic behavior of the structure. And vice versa, when we do the design, we also need to consider how the maintenance work can be facilitated in a later stage. For instance, we already know that the most effective damping frequency is 45 Hz. Then in the design phase, we need to think about if we can avoid this resonance in our bridge design, or we can introduce some other boundary conditions or enforcement to avoid to change the eigenfrequency of the structure. So the conclusion is that we should always consider them together: the maintenance, the design, and the operation. The last question is more related to the capacity. That is about the conflicting interests of different parties. For instance, for the operation, we have in the Netherlands we have the NS company, and for the maintenance we have ProRail. And when we do the maintenance, we need to try to optimize the schedule, the timetable of the operation to influence as less as possible to the passengers' use of the railway. And when we and another thing we need to consider is the coordination between different parties, like the maintenance parties. Well, one example can be for the transition zone. For instance, in Netherlands, the tracks belongs to the ProRail, the company ProRail, and the subgrade, the ground part, it might be, belongs to the Ministry of Water and Transportation, and for the bridges, it may becomes to another company. So we need to coordinate all the interests of the different parties while we do the maintenance, also do the design. Okay, then that is the questions we have learned we have received from students, and we hope in the future stage there are also some good questions like this can be raised, and we are willing to discuss with you and provide you with the answers. Thank you.